Okay, so Josh, can you hear me all right? Is my voice all right?
Yes, all right.
All right, okay. So thanks, Josh. All right. So I'd like to thank you for wanting to participate in the development of VastVerse, okay? And actually maybe helping out with the development of the VAST library. And I'd like to take maybe about 20 minutes to just walk you through what this is about, okay? So just kind of curious, have you had a chance to download and look at the VAST source code yet?
Yes.
Yes, okay, all right. So if you can, maybe if you can show your screen of the repo. And I think I'm going to, I guess, quickly explain about basically what we plan to do and what parts might you contribute. Would that be all right?
All right.
Okay, so are you able to share your screen for the VAST source code?
Okay, wait a minute.
Okay, all right. So before you do, maybe I'll also share the screen for those who just got to this, okay? Okay, please prepare. And this is basically the VAST repo, okay? It's at GitHub under immunology, vast.js. Okay, so Josh, I think you have cloned this repo, right? Is that right?
Yeah, and I forked it.
Okay, you have fork this repo. Okay, great. All right. So yeah, so please, I think maybe once you're ready, let me know. Okay, and this is essentially just quickly some of the resources that's related. This is one repo, and the other one is the VAST SourceForge. Okay, sf.net or sourceforge.net. This is the original C++ version of the library. And also there's also research papers under the publications. Okay, so basically for those who might learn this the first time, the goal here is to build a library, actually an infrastructure that can support a peer-to-peer based decentralized infrastructure for supporting spatial publish subscribe. Okay, and there's a YouTube video, okay, that describes what this looks like. This was actually run with the C++ version. Okay, and some publications are here, and these top three are actually the most important. Okay, so you're just starting up. I encourage you to look at these three papers, okay, just to have a quick idea. All right, so just are you all right? Are you ready on your side? I mean, are you able to share screen now? Hello? Hello?
Can you hear it?
Yes, you have some background noise. That's kind of okay. Or maybe I can also share screen on my side, okay, to just show the code repo, okay. And maybe another way is I'll explain, and if you have any questions, just ask. All right. Okay. All right. Okay. Okay. So I think it's a bit noise there. Okay. All right. So basically, there was a C++ version, okay, at SourceForge. If you go to the download section, that's where you can download this library C++ version from here. And the version that we'd like to work on now is actually the JavaScript version. And this is actually a direct porting, okay, of the original C++ version. So very quickly, I'd like to explain the code structure of this library because I think right now our goal is to basically build an application, okay, that can utilize this spatial PubSub for two application scenarios. One is an instant messenger, direct one-to-one communication, just like a line, like Line or WhatsApp. but using a more distributed mechanism, okay, decentralized mechanism for the message delivery. And the other is what's maybe called an open source Uber, okay, kind of application. And those two are expected to be built upon the VAS.js library. Okay, so what happens, I think, for Josh is that right now there are 3 main components, I think, that's involved in terms of the library side. One is, okay, to basically support, well, I would say there are probably 3 parts, okay. One is to support the simply spatial PubSub, okay, which means that, you know, as a node, you can join a network, you can publish, as in the pink, okay, to an area, or subscribe, as in blue, of an area. And if the 2 overlap, you get the message. Okay, it's kind of like channel-based, but you're using areas to determine whether a node receives the message. Okay, so this is the PubSub part, spatial PubSub. And the second thing is actually what may be called a forwarding model. Okay, so this is the idea that because you know, potentially a node might subscribe or publish to multiple areas, okay, or even very large areas, right? Think of, let's say, you know, like a city, right? If there is a, let's say, a monitoring mechanism, you might want to monitor like all the air pollution sensors in a city, right? Then you might want to subscribe for a whole city worth of data. That's a lot. Okay, so there's probably no way that a single node or a single server can handle that much data collection. Okay, so first off, we need to have a sort of a multiple node, or in our terminology, multiple matcher mechanism. But the other thing is you might need to use what's called a forwarding model. Okay, so I believe this is the paper, okay, where the number 4 here, a forwarding model, okay, for Voronoi based overlay network for VON. That was actually the paper that, let me just try to see. Okay, there's a diagram here. Okay, that actually shows a simple idea of the forwarding model, which is, you know, if you are subscribing or publishing to this area, okay, let me see if I can enlarge this. So can you see it now?
Yes.
Okay, all right. Okay, so I think the idea is that if let's say you are publishing, right, to this area, okay, but you are only connected to a few of your what's called enclosing neighbors, the nearest neighbors, then what you can do is you first forward it to your first layer neighbor, and they will in turn try to forward to the next layer, right, until everyone is being reached within the circle. Okay, so this is called a forwarding. And you can think of this as, you know, if you're publishing or subscribing to a really large area, you can actually utilize the forwarding mechanism without having to make direct connections to all the nodes within this circle. So does that make sense?
Yeah.
Okay, so this is actually a mechanism or an algorithm that has to be implemented. And right now, this forwarding mechanism is missing in both the C++ and the, you know, and obviously the JavaScript version. Okay, so this is only existing in concept, but not in implementation. Okay, is that right? Okay, and Josh, you understand this part, right?
Yes.
Okay, and actually the spatial PubSub, that is actually being implemented. Okay, I think in both the C++ and the JavaScript. But this forwarding, I think it's you know, right now it's only in concept. All right, so this is the forwarding model, and the third part may be called the load balancing. Okay, So for the load balancing, I like to refer to this. Okay, just very quickly to show you the, have you watched this video before? This YouTube video I'm sharing?
No, I've not.
Okay, all right. So I think this is probably useful. Let me just, I don't think I can. All right, all right. I'll just play it. Okay, I think it's, you can have a look at this. Okay, I see the problem. Okay, so maybe I'll move it to here and share this in YouTube. Okay.
If you want to sell online, make sure you
all right. Sorry.
Stand out. Go to Wix e-commerce and create a professional online store.
Okay, all right. So this is actually so VONG, Voronoi based overlay network. It's the idea of using Voronoi partition to connect the nodes. Okay, and here we are actually utilizing VONG and use a bunch of nodes called matchers. Okay, so you can imagine them as region managers. Okay, sort of, they're responsible for all the PubSub or all the positions management within a particular region. Okay, Josh, is that all right? This is called a matcher.
Yes.
Okay. Okay. So what happens is as nodes move, so here actually each client nodes connects to a particular matcher in a client server fashion. Okay. So right now you can see that, for example, this center node, it's actually a client. It's moving and it's also seeing all the other neighbors within its area of interest or its visibility, right? However, it's behind the scene, it's supported by many matchers, not just one. Okay, is that okay?
Yes, okay.
Okay, so this is, I mean, you can see Voronoi partitioning at work. And the interesting thing is, you can do dynamic load balancing this way. Okay, by simply shifting what's called the sites of each matcher's position. Okay, so you see the region behind, they are constantly adjusting their shapes, right, and their sizes. And the reason is that they are constantly adjusting their position, the matcher position, to fit, so that each region manages roughly the same amount of nodes. Okay, so this is actually a automatic dynamic load balancing. And why is this important? Because in reality, the node distribution and density is uneven. Okay, it's usually following some kind of Pareto principle, 80-20 principle, where most areas are empty, but a few areas potentially are overloaded, or with a lot of nodes. Okay, so right now, this is the load balancing part. But I think for our task at hand, we are only dealing with the first two. One is to support spatial PubSub, okay, and from a single matcher to multiple matchers. And the second is to support forwarding model. All right, so is that understandable? Is it clear?
Yes.
Okay. All right, so I'm going to talk a bit about the code now. Okay, so as you can see, there's the master branch, which hasn't been updated for quite some time. Okay, it's been 6 years ago, 7 years ago. That was, that's how long it was. Actually, the whole work started in 2003 when I was doing my master. But there's a development branch, okay, which may be a bit more recent. Okay, you can see some sites 2 years ago. So this is probably when Migro, one of Herman's students, was working on this. And there is I think a most recent branch called SPS forwarding. Okay, So this is probably the most recent, okay, but right now I think it's just a fork. There hasn't been any code change to this. But this is the one where Victory is right now playing around. And let's see, okay, so the DEV branch, I think that's the one Migro was, he was basically working on this. And also he did use this to support Minecraft servers. Okay, in order to increase the number of players that can join a Minecraft server. According to Herman, I think some of the code here might be hardwired to work with a Minecraft implementation. Okay, that's one of, but I think this is the code base for the DEV branch that we should be, basically using and basing our work on. Okay, so all right, so I'll just quickly explain the code structure here. Obviously, there's the test, right? Test directory. That's where all the basic tests are, shell scripts and batch files. This is when run under DOS, Windows. And I think this is how you can start what's called a volunteer. Okay, and there's also HTML file where you can do an interactive Voronoi test. Okay, I don't know if this actually loads, but okay, probably not. Okay, but this is something you can play around with. And the library directory, okay. So this is something that worth a little bit explanation. In the library, VAST library itself, at the bottommost, there's a network layer. Okay, so this network layer is actually designed to be fairly independent and also neutral in the sense that it has nothing related to Voronoi or VAST. Okay, it's actually a simple interface. If you look at the VAST_net, this is where all the network communication is being abstracted to the idea of sending a node ID a message. Okay, so you can do something like you can store a mapping between an ID and an address, which is simply an IP and port pair. Okay, and then you can also send to a particular ID. Okay, it could be an array if you are sending to multiple, a byte stream, and whether it's reliable or unreliable, and get notified when it's done. Okay, and you can also listen to a particular port like a server. Basically, any nodes that connect to you, if they send a message according to this format, then you will be, you will receive through callbacks. Okay, is it so far clear regarding the network layer?
Yes.
Okay, all right. So this is an abstraction. Okay, and besides the network layer, the other part is the Voronoi. Okay, so this is actually also very simple, just a few files. And the interface that it provides is actually, because for Voronoi, let me just see if we can find an example. Voronoi Wikipedia, okay. A Voronoi diagram, okay, it's actually determined by what's called sites on a 2D plane, okay, like this, right? So this is 20 points. And then it's done such a way that you draw a line between every 2 points in the center, in the middle of it, okay? So if you've done this, you actually have a partitioning of the space where you can imagine all the nodes within a region. The closest site is actually the site in the center, the controlling site here. Okay, so this is what's called a Voronoi diagram. And our library here is meant to calculate the edges of this Voronoi diagram given a bunch of sites. Okay, is that all right, Josh? Okay, all right. So you can see that there's insert, right? You insert given an ID at the position. You can also remove an ID, or you can update its position to a new position, or get the position for a given ID. okay, and clear all the sites, okay. And then after this is done, the Voronoi is calculated automatically, and where you can do some simple operations like contain, like if this position is being contained within the region of this ID, okay, and whether it's a boundary neighbor or it's an enclosing neighbor. Okay, so for example, if this position, okay, is a site, okay, so basically you can check if a site is a boundary neighbor to a given position or an enclosing neighbor. So the concept here, boundary and enclosing, is like this. I don't know if we can have a picture here. But okay, if you go to the publication and if you go to the very first paper on VAN, okay, VO1, Voronoi Overlay Network, you can see a simple diagram that basically explains the boundary and enclosing concepts. Okay, so the yellow are the enclosing neighbors. Okay, and the blue are the boundary neighbors, which overlap with the what's the area of interest or the radius. And the pink are both. It's both boundary and also enclosing. Okay, is this so far okay, Josh? Okay, if there's any question, just ask. All right. Is this okay?
Okay, just wait a minute.
I'm sorry?
Just wait a minute.
Okay, all right. All right, so let me know when you're ready, okay?
Yes, can keep going now.
Okay, all right. So I was asking, is the idea of the boundary and enclosing neighbors all right? Is
yes,
it
all right.
understandable? Okay, all right. So the library here, actually, you can check if a position is a boundary neighbor or an enclosing neighbor. Okay, basically, this is comparing two IDs. Okay, if a site is the enclosing of another site. Okay, so these are simple and also overlapping. You can check if a position and radius, okay, overlaps with the region of a particular site. Okay, so this is very useful if you want to check if, let's say if an area is, or, a position and radius is overlapping with a region's, a region's area. Okay, and also you can find the site closest to a position. So these are some of the operations offered by the Voronoi overlay. Okay, so is that okay?
Yes.
Okay, all right. So once you have these two building blocks, one is the network layer, the other is the Voronoi. Basically, you can build a VAN network, a Voronoi overlay network on top of that. Okay, and basically it forms an overlay. And the interface of which I think it's the VAN peer. Okay, so this is what you can do to a Voronoi overlay, which is the basic operations are you can join, at the location, which is represented by an AOI, which is simply a center and a radius. You can refer this about, okay. You can join, you can leave. I think we have Alida joining us. Okay. All right. So yeah, Alida, I'm explaining the source code for Josh. Okay, so you can. This is maybe something you already know. Okay, but just quickly. So for the VAN peer in the vast.js library, you can join at the location. With an address, you can leave the network. You can also move to a new location, new AOI. And this is listing all the neighbors that you have discovered. And you can also send a direct message to a neighbor with a byte string. Okay, so these are actually the most basic and fundamental Voronoi overlay VAN network functions. And basically this manages the peer-to-peer overlay network to ensure that it stays connected. Okay, that is it making sense so far, Josh?
Yes.
Okay, all right. So basically, I think, like for example, like Alida right now, if trying to make sure spatial pops-up works, it's probably going to work on top of this. Okay, to add spatial pops-up functionalities on top of the Voronoi overlay network. Okay, and there's actually also, I think, already a spatial pop-up interface that's here, which is the VAS client. Okay, because VAS was meant to be a spatial pop-up library with a relevant interface. Oh, sorry, I think this is actually a sort of a test code with you know, trying to initiate a peer. So let's see, the interface may be, I think, okay, so this is, all right. Okay, so I think it's somewhere here, but okay, because our sync will start now. So, okay, I'll leave it here. Okay. All right, so I hope this provides a basic, you know, quick tutorial for Josh. Okay, and you can always refer back to the recording. Okay. All right.